Hey guys. So today we are talking about standard deviation, and let's get started. All right. So the warm up, I can't write on this, or I'm not sure how to. I don't, I usually write on my iPad and you just hear my voice. But for the warm up, you should have done the box method. And if you put the factored form, right? So x plus 3 goes on the side of the box, x plus 3 goes on the top. And if you do that, you should have gotten this expression way over here. So x squared plus 6x plus 9. This is the standard form version of this. And if you forget the area method, put them both into your y equals. So y1 can equal expression A like this factored form, and y2 can equal the next, this last expression, right? And so those should be identical on your calculator when you graph them or look at the table. Okay, so after that review, we're talking about standard deviation. So standard deviation is a statistical measurement that just finds the mean. So that's really important. You guys figured that out last week. So to find the mean, you add up everything and divide by however many numbers you added up, right? So you find the mean, and then you look at all of the numbers and think, are they pretty close to that mean? Or are the numbers really far away, like a far range? So if I were to give a test and my average test, if I added up all of your scores and divided by however many students I had, let's say that was an 85, right? Then a large standard deviation would be looking at all of the test scores and seeing, oh, someone got 100, someone got a 90, someone got a 62, someone got an 83, someone got a 45, right? So the numbers are really spread apart from the mean, which again was 85. Now, let's say I had another class and their average was also an 85, right? I added up all the numbers, divided by my students, the number of students, and I also got an 85. But then when I looked at their scores, I found out, oh, this person got an 89, this person got an 82, an 84, a 90, a 79. All of those numbers are pretty close to 85. I'm not getting the 100, 45, so all of those are pretty close. So that would be a much smaller standard deviation. All right, so here's the example. I forgot to say, so both of these, the population standard deviation is done exactly in the same way that a sample standard deviation is done. The difference is the sample has this S and the population has the theta. Now the population is the entire thing. So if I were to do coronavirus testing, and I were to test every single person in the United States, that would be the full population of the United States, right? And then I could see what the deviation is. Now that's a ton more accurate. You get a lot more accuracy when you do the entire population. But it's not realistic. Sometimes you don't have enough money, you don't have enough time, you don't have enough supplies in order to test that many people. But you still want to find a sample of, maybe 100 people, maybe a community. So you test little samples that are much more manageable in order to do practically. And you can use that data to kind of make a valid prediction of, the entire United States, if we're going along with that. Okay, but it's the same formula, the same thing. I really am just measuring how far each of my data is, each of the test grades is from the standard deviation, and then using my formula to find this out. Okay. All right. So formulas here. In this case, they chose the population one. It depends sometimes on the problem. But for these, if we're going to assume that this is student A's all of their test scores. So let's say that this is the population, that we're doing, right? So the total, so every single test score that this student has so far. It depends on the problem. Sometimes it'll be like, oh, here's a sample of like 3 grades out of however many. All right, so let's figure this out. So the formula is the sum. This E symbol means the sum. That just means add them all up, of the X value, which these are all of my X values, the test scores, minus the mean squared, right? So I add up, right? I take whatever the X, so like 84 minus, and let's say 85 is the mean here, and I actually think it is. So that 84 minus 85 would be -1, and -1 squared is 1, right? So I would do that for each of these. 86 minus 85, that's 1. 1 squared is 1, right? So I would do this X term minus 85 for all of them, square it, and then add up all those deviations. All right, add them up, divide it by 1, 2, 3, 4, 5, because there are 5 numbers, right? Divide it by 5. This n means just however many numbers you have. Take the square root of it, and that gives you your standard deviation. Now, again, not ideal. I hope that's not too confusing because I can't write on it. And so we are going to use our calculator. All that to say. Okay, so here is, oh, I already did it actually. All right, so in order to calculate the statistics, there's actually a statistics button. Stat. All right, so the one in red right here. So the first thing I'm going to do is to edit it. So let me just press enter. And if there are numbers in here, right, I actually was in here before, so they're the numbers in your data set. But if there's just random numbers, scroll all the way to the top, highlight the L, L1, L2, right, whatever L you're on. L stands for list. And press clear and followed by enter. So clear and then followed by enter. Now, I'm just going to type these in. 84, 86, 83, 85, 87. Okay. So just make sure that you put them in correctly. Now I'm going to hit stat again. And this time I want to calculate. I want to know, well, what is the average? What does that mean? What is the standard deviation? All right. So I'm going to go over to calc. I need to hit this little arrow button. One variable stats. And it's this one variable because I'm only talking about X values, right? I'm only talking about these test scores. Okay. So I'm going to calculate that. I'm going to press enter. And I'm going to press enter, 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 calculate. Okay, so now it gives you this. The mean, the average is 85. So if I were to add up all these scores and divide by 1, 2, 3, 4, 5, I would get 85. This big E, it looks kind of like a weird E. That's Greek for the sum of. So if I added up all of the X's, I would get 425. So if I said 84 plus 86 plus 83 plus 85 plus 87, that would give me the sum of X, which is 425. Okay. Now, if you notice, here's that S that we were talking about, right? That standard deviation for the sample size. And here's that theta, right? So this is a sample deviation, or sorry, my cat is right here and he is just being annoying. Okay, goodbye. Okay, so where was it? So the sample deviation is the S, the population standard deviation is this theta, that Greek symbol. So it would be 1.4. So 1.4 is my standard deviation. All right, so now is that kind of high? Is it kind of low? I look at all of these, and if my standard, or if my mean, my average is 85, all of these kind of look close to 85. This one even is 85. So I would assume 1.4 is kind of a low standard deviation. So let's compare it to the next one. All right. So here I'm going to go back to stat. I'm going to go back to edit. And this time I'm going to go up to L1, clear, enter. All right. So now 90, 75, 94, 68, 98. And I'm already looking at this thinking, hey, these numbers seem a lot further apart than student A, who's all in the 80s, right? Okay, so now same thing. I'm going to go back to stat, calc. So I need to use this arrow. One variable stats, enter, enter, enter. And here, the average, the mean is 68. Okay. All right. Now, the standard deviation, again, we're going to assume that this is all the entire population of student B's grades. So we would say 31.94 is the standard deviation there. All right. So that's a lot higher. That means that those grades are a lot further away from 68.8 than student A. Okay. So that is pretty much it. If you have any questions, comments, or concerns, please Google, email, talk, struggle, but make sure that you're struggling productively. A good example of that is someone that tries the warm-up, tries reading through, struggles, is kind of confused, and then watches the video, right? And it doesn't have to be an hour struggle. It could be like a good 10 minutes of struggle, right? Okay, so that's it. Now let me figure out how to turn this off. And I miss you all very, very much. And I really hope that you guys are doing well. Oh, I'm also going to stay for 10 seconds. Please answer any questions Mr. Q puts on here. It does count as your exit ticket.